Dr. Cerf, it's a pleasure to meet you again. It's been quite some time. I think we first met in 2010 when you were speaking in Raleigh, North Carolina with Sir Tim Berners-Lee and talking about where the internet, how the internet came about, how the World Wide Web came about, and what is going to happen in the future, what you predicted was going to happen in the future.
So it's a pleasure to see you again, and of course now we have a chance to test whether any of our predictions 9 years ago came true or whether we have to make more predictions.
I'm not going to take you to task over the predictions that you made in the past, but I will ask the question, what's coming up next?
Fair enough.
Because as I understand it, this whole idea of transferring ones and zeros back and forth between computers, it was a pretty good idea, it sounds like.
Seems to have helped us do a lot of things that we couldn't have done otherwise.
I'm a technologist, and you're a technologist. You're at the pinnacle of technology. We were sitting here at Google headquarters. How did you explain this technology to a whole world of lay people? Because no one understood what the internet was.
Well, but the good news is I didn't have to do that, at least not at the beginning. Remember, this was a Defense Department experiment. It started in 1968 or so. The network began operation in 1969. In fact, we're about to celebrate on the 29th of October the 50th anniversary of the connection of the first two nodes and computers on the ARPANET project, the predecessor to the internet, at SRI International in Menlo Park, California, and at UCLA in Los Angeles. So on the 29th of October, the machines on the network and the two packet switches that we call interface message processors, or IMPs, were interconnected for the first time. So it didn't require selling anything because the Defense Department wanted to build this for purposes of resource sharing, because they had a dozen universities that were doing research in artificial intelligence. And they concluded that the right thing to do was to link all of the computers that were being used in this research together so that the researchers could share their results and share each other's resources instead of having to buy new computers for everybody every year. So we built the ARPANET for that purpose. Once the ARPANET was successful, it became clear that this packet switching idea had some real legs. We had, around 1973 or so, Bob Kahn, who had worked on the ARPANET project for a company called Bolt, Beranek and Newman, came to my office at Stanford, where I was just beginning to do some additional research in networking after having had the ARPANET experience at UCLA. And his idea was, how about using computers in command and control? Use the algorithms on the machines to manage the resources of the Defense Department more effectively than an opponent. But in order to do that, the computers had to be available in mobile vehicles, ships at sea, and airplanes. And up to that point, all we had done is hook computers together that were in fixed locations in air-conditioned rooms with dedicated telephone circuits. So Bob arrived saying that we needed satellite networks to do ship-to-ship and ship-to-shore. We needed mobile radio networks for airborne and for mobile ground operation. And he had already started working on and thinking his way through these additional networks. So that was the internet problem. So I didn't have to explain that to the cohort that did the original ARPANET work or did the internet work. The place where we had to make some serious, do some serious persuasion came with the arrival of non-military participants. So the Department of Energy, which was using computers for a lot of its work, NASA, which was using computers, and the National Science Foundation, all civilian agencies, had to be persuaded that this technology that had been developed by the Defense Department initially for a command and control system would be useful for their purposes. And we were successful in convincing them of that. And again, it wasn't too hard because they were technologists. This wasn't the general public, this wasn't the commercial sector. Getting the commercial sector and the general public to understand why this was useful was a whole other matter. And that revolved around applications. It had nothing to do with the basic technology. Nobody cares how the basic technology works. What they care about is an application that works. And so getting the general public drawn into this was a matter of getting companies to understand there was a business to be had supplying internet service, a business to be had selling equipment that knew how to do internet, a business to be had creating applications that other people would buy. And so that process begins in the late 1980s, around 1989, in fact, 30 years ago. And that's when we started to see commercial internet services coming. There were companies like Cisco and Proteon and others that were making equipment to help people build networks. The Ethernet development at Xerox PARC and Sun Microsystems workstations, for example, and the development of Unix and outfitting it with TCP/IP, the Internet protocols, enabled a lot of academic acquisition of software, hardware, and service. And then the general public gets access to it starting in 1989. But the real trigger that caused the general public to discover this stuff was the arrival of the World Wide Web in December of 1991. Tim Berners-Lee announced the existence of his World Wide Web design, which layered right on top of the TCP/IP protocols of the Internet, and nobody noticed, except for a couple of guys at the network, what was it called, the National Center for Supercomputer Applications in Champaign-Urbana, Eric Bina and Mark Andreessen. They developed the Mosaic browser, which was a graphical user interface version of the browser, of Tim Berners-Lee's text-based browser. That allowed the internet to look like a magazine because it was formatted text and imagery and streaming audio and eventually streaming video. That grabbed a lot of attention. And the existence of the hypertext markup language and the web page concept enabled lots and lots of people to put information on the internet that they wanted to share with others. And so there was this avalanche of content that flowed in once the Mosaic browser showed up. And that was swiftly followed by commercial versions, for example, Netscape Navigator, and the Netscape company, which was started by Jim Clark. Well, it was actually Jim Clark, who had built Silicon Graphics.
Right.
Also inaugurated Netscape Communications, and with Mark Andreessen and others who had come from NCSA. And so that triggered this gigantic explosion of content on the net. And after that, you didn't have to explain very much because people didn't really care how it worked. They only cared that you could find stuff on the net and make use of it. Then we run into the problem of it exploded in content, just endless websites being created, which caused us to have to invent search engines so you could find stuff in this giant ocean of information. Hence the arrival of things like Yahoo and Google and Bing eventually from Microsoft. There were predecessor systems like Alta Vista that in Palo Alto, where it was a text-based search engine. And it was in its day, it was one of the best search engines available, but it was overtaken by these others. So all of these things happen because they're forced on us out of need. And so coming back to your original question about how did you convince people to use this, we didn't have to really. Once the tools were available, once the content was discoverable, once people found the ease with which they could create and share content, this all took off like a rocket.